In the last few videos, we've been looking at the binomial expansion for positive integer powers. We're going to continue that work and now look at the expansion of 1 plus x to the n. This is given in the formula book, and we can write the first few terms of 1 plus x to the n as 1 plus n multiplied by x plus n multiplied by n minus 1 multiplied by x squared all over 2 factorial. Remember, 2 factorial is just 2. It's 2 times by 1. Plus n, then we'll have n minus 1, we'll have n minus 2, we will have x cubed, and we will divide this now by 3 factorial, and it will be plus dot dot dot, and so on and so forth. So the next one, n minus 1, n minus 2, n minus 3, x to the 4th over 4 factorial. 4 factorial is just 4 times by 3 times by 2 times by 1. The advantage of this particular approach is that n doesn't have to be a positive integer. So we could have now a negative number or a fraction. In later units, you'll need to be able to use this particular approach. The NCR method for finding coefficients is not valid when we have a negative or fractional value. So this is what you get in the book. A slight alteration or variation of this is 1 plus ax to the n. We can write this now as 1 plus n multiplied by a multiplied by x. Plus n, then we'll have n minus 1, we'll have ax, which we need to square, and divide by 2 factorial. Then we'll have n minus 1, we'll have n minus 2, we will have ax, which we need to cube, and divide by 3 factorial, and then add, and so on and so forth. In later units, when we look at infinite series expansions, we will consider the values for which these are valid. When we're using positive integer powers, then that doesn't come into it. So the reason I'm using this one right here is often students just put x in. So for example, if we had 1 plus 6x, they would just put x. 6 would be a. The slight disadvantage of this is that we have to have 1 in the bracket. If we don't, we need to take that out to the power of n. We're going to work through a few different examples and just go ahead and look at how we can do this. So what I'm going to do, let's just go ahead and we'll just copy this, and we will use this as we go. So either one you can use, entirely up to you. Okay, in question 12, it says use a binomial expansion of 1 plus x to the n is equal to 1 plus nx plus n minus 1 x squared over 2 factorial, and so on and so forth, to find the first 4 terms in the expansion of, and then we got a few here. So let's just put this here. This is going to be the one I'm going to use, and we're going to start with this first one. So if we just look, we've got 1 plus 2x to the power of 9. So on here, of course, we could use the NCR method, but we're going to just use this particular approach. So n in this one is going to be 9, and a is going to be 2. I'm simply going to feed this in now and find the first 4 terms. If I needed the next term, I'd simply have n minus 1, n minus 2, n minus 3, ax to the 4th over 4 factorial. So let's go ahead. 1 plus 2x to the power of 9 will be equal to 1 plus, now n is 9, so we've got n multiplied by a multiplied by x. So I'm just going to write this as 9 times by 2x plus 9 times by 8, then we're going to have times by the 2x, which we're going to square and divide by 2 factorial. 2 factorial is 2. Plus n minus 1, n minus 2, then we're going to have the 2x, which we need to cube, and divide by 3 factorial, which is 6. All we need to do now is go ahead and simplify this. Be careful, and this is why I'm saying be careful. This isn't 2x, it's 4x squared. So we're going to have 1 plus 18x. Now if I consider what this is going to be, this is going to be 9 times by 8, which is going to give me 72. And then this is going to be times by 2. So this is going to give me plus 144x squared. You can, of course, do that on a calculator if you're unsure. 9 times by 8 times by 2 squared, or 4, divided by 2. Whatever you do, don't mess these up, because the greater these are, the more error prone you are. Also remember, if you have negatives, when you have a negative and we have an odd power, it's going to be negative. So on the next one, let's go ahead and do that. So what we're going to have now is the following. We're going to have on here, and you could simplify, I'm just going to type it in, 9 times 8 times by 7 times by 8. Remember, 2 cubed is 8, and then we're going to divide by 6. Common factors in here, but just easier to write it in. 672. So plus 672, and then that will be x cubed. Now, of course, we could have used the NCR method here. We could have said that this is going to be equal to 9c0. We'd have 1 to the power of 9. We would have 2x to the power of 0. Then we'd have now 9c1. We would have now 1 to the power of 8. Then we would have 2x to the power of 1. Plus 9c2. We would have 1 to the 7th. We'd have 2x, which we need to square. Plus 9c3, we'd have 1 to the power of 6, and then we'd have 2x to the power of 3, and so on and so forth. Remember, we're going to have more terms. If we expanded it fully, we'd have 10 terms as we're going up to x to the 9th. 9c0 is 1. 1 times 1 times 1 is 1. 9c1 is 9. 9 times 1 times by 2 is going to give us 18x. Now, finding 9c2, what we could go ahead and do is simply 9 times by 8 divided by 2, which is 36, and then times that by 4. Again, if you're unsure, just put it in a calculator, 9c2. So 9c2, there's our 36, and we're going to times it by 2 squared, so times that by 4, and that's our 144. So plus 144x squared. 9c3 times by 8, we'll put that straight through a calculator, so 9, then we're going to have c3, and we're going to times that now by 8, and that will give us our 672 as expected. So we can see that either method is perfectly fine because it's a positive integer power. We couldn't have used this approach if, for example, down here we've got a half. Now a half doesn't come into this unit, but I thought I'd introduce it nonetheless to show the advantage of this particular approach, because it's often a hard sell when you've done so much work to then go ahead and do this. Okay, let's now again use the expansion of 1+, and you might want to just have 1+x to the end. It really doesn't matter. I think just the advantage over here is that we just give a little not respect necessarily, but just appreciate this ax. So here n, we're doing part b, n is going to be 7. And then we've got a is going to be now negative 1/2. So negative 1/2 or negative 0.5. Again, we can use this here because we've got 1. With this one, we're going to have to take the 3 out. It must be in the form 1+ax. So don't be tempted now to leave that as it is. We're just going to have to take that out. But we'll come to that shortly. So what we've got then is 1 minus 1/2x, or 0.5. You can write it in either of these forms. So let's do that. So 1 minus 1/2x to the power of 7. So we're going to have 1 plus n, which is 7, multiplied by ax, which is negative 1/2x, plus n, which is 7, n minus 1, which is 6. Then we're going to have now negative 1/2, which we need to square. Now at this stage I could put this all over 2 factorial. The advantage here of using a different approach is that we're not going to confuse ourselves. 2 factorial is 2, so I'm just going to multiply this by 1 over 2. That just makes it look slightly easier. You don't have to, but it's a choice for you. 7 times by 6 times by 5 times by now 1/2, which is negative. We need to cube this and divide this by 3 factorial, which is the same as multiplying by 1 over 3 factorial, which is going to give us now 1 over 6. So let's write this out. So we're going to have 1 minus 7 over 2x. Okay, what I'm going to do on this one is just type it into the calculator. 7 times by 6 times by negative 1/2 squared. This is going to give me now 1/4. So times by 1/4, and that will be positive as we've got an even power, and then times by 1/2. You might say to yourself, I don't like doing it that way. Perfectly fine, entirely up to you. Do as you wish. 21/4, so that's going to be plus 21/4, and then we can have x squared. If we look at this one right here, this is going to be negative, as when we cube a negative, it will be negative. So what we're going to have then is 7 times by 6 times by 5 times by it now, and then we're going to have negative 1/8. Again, you can just put that in a bracket if you want and do that, and then we're going to times this now by 1/6. So 1/6, and that's going to give me now negative 35/8. So negative 35/8, and that will be now x cubed, and plus ... and so on and so forth. So there we go. That's what we have when we go ahead and expand that using this particular approach of 1+x or 1+ax to the n. Now, if you wanted to check that this is correct, we could use now a tool to do that. So if we use Wolfram, we can go ahead and put this in, and whilst it will give us in decimals, we can work out whether we've got this correct. So 1 minus 0.5x to the power of 7. That's what we've just done. Often this writes it in descending powers of x. Generally speaking, we would write it in ascending powers of x, but it should give us the expansion. So here we are. 1 minus 3.5x. So 7/2 is 3.5. So 1 minus 3.5x. Then we've got now 5.25x squared, and that's positive. So if we look at that just here, that is what we've got now just here. So if you wanted to check that, 21/4 is that. So if we just look at that on a calculator, should be happy with that anyway, but we can go ahead and check. So that's for 5.25. Now if we look at the next term, what we've got is 35 divided by 8, which is negative, and that is negative 4.375. So if we look at that one, negative 4. Where are we? There we go. Negative 4.375, which we've got just here, and that is what we had. So there we go. You can use that tool. Obviously, you can't use that in an exam, but it just makes sure that you've done the correct thing, because these are prone to massive errors if you're not careful with your work. Okay, let's do the next one. So let's just put my expansion back. Again, this will be to hand if you want to use it. So we've got 1+x/2. So in this particular case, a is a half and n is going to be 6. So a is equal to 1/2, and then we're going to do n is equal to 6. So what we've got then is 1 plus 1/2x, or x/2, exactly the same thing. So this is going to give us 1 plus 6 multiplied by 1/2x. Then we're going to have plus 6 multiplied by 5, n minus 1. Then we're going to have this value, which we need to square. Now I'm going to write this out as 1/4 x squared. That is 1/2 x squared, and then we're going to divide all of this by 2 factorial, or multiply it by 1/2. Entirely up to you. Plus 6, 5, then we're going to have 4, then we're going to have now ax, which we need to cube. So that will be 1/8 x cubed, and then we've got 3 factorial. 3 factorial is just going to give us now 6. 3 times 2 times 1. So that's 1/6, plus ... and so on and so forth. If you're unsure, you can simply find 3 factorial and just type in 3, and then it's shift and then x to the -1 button, and that will give you 6. 4 factorial should be 24, so if we go ahead and do that, because we're just multiplying that answer by 4. 5 factorial is 120, because we're timesing that by 5. If we do 5 times by 4 factorial, this is 5 factorial, because we're simply now doing 5 times by 4 factorial, which is the same as 5 times 4 times 3 times 2 times 1. So n times by n minus 1 factorial is just n factorial. And that's the reason that 0 factorial gives us 1, if you want to investigate that. Entirely up to you. Okay, next one, D. D is slightly different. We need this in the form 1 plus ax to the n. We need to take the 3 out. So if I just put this up again, let's just put, you might be bored of having this here, it's entirely up to you, but I thought just for this particular video, whilst we're getting used to it, we're going to use this approach. So what I'm going to do is take out the 3. When I take out the 3, I need to take that to the power of 10. That's going to leave me 1 minus x over 3 to the power of 10. So by taking it out, I need to raise by that power. I'm taking a factor of 3 out of the bracket. So that'll be 3 to the 10, 1 minus x over 3 to the 10. So what we're going to get is 3 to the power of 10. Then we're going to get now, just consider that a is negative 1/3 and n is equal to 10. So we're going to get 1 plus n multiplied by ax. Well, n is 10, then we're going to have 1/3 x, and that's negative, plus n, which is 10, n minus 1, which is 9. Then we're going to have now negative 1/3 x, which we need to square. That will be positive 1/9 x squared. In your working, you can go ahead and write it's negative 1/3 x, which you need to square, but you must consider the actual answer. Okay, and that is going to be multiplied by 1/2 or divided by 2 factorial. We're going to have n, which is going to be 10, n minus 1, which is 9, n minus 2, which is 8. Now we need to cube this term right here. That term cubed is going to be negative 1/27 x cubed. And then we need to divide by 3 factorial, which is 6, or multiply by 1/6. And that will then allow us to close the bracket. Right, so let's see what we're going to get here. 3 to the 10th is a pretty big old number. So let's just write it out now. What we'll have, 3 to the power of 10. Inside the bracket, we're going to have now 1 minus 10 over 3x. Generally speaking, we'll be asked to write these as simplified fractions, so in their lowest form. Okay, the 9s are going to cancel, so this is going to be plus 9 over 9 is 1, 10 over 2, that's going to give plus 5, and then we're going to have now x squared. Okay, with this one here, we can look to do a bit of simplifying. I've got a feeling that's going to be negative 40 with a bit of calculation in my head, but I'm not going to risk it. So let's just go ahead. So 10 times by 9 times by 8 times by negative 1/27. You can just do 1/27 and just make your answer negative. So negative 1/27, and then we're going to multiply that now by 1/6. So is this negative 40? Negative 40 over 9. So let's just check I've got all that. A negative 40 over 9. So that looks good. So negative 40 over 9. And that is going to be now x cubed. So then we'll have the other terms. I'm not confident I've got this correct. So again, if we wanted to check, I'm just going to look at this expansion right here before I multiply through by 3 to the 10th. So what we've got then is now 1 minus, and we'll write this now. So 1 minus, and then we'll have now x. Hopefully it'll allow me to type it in like so, x over 3. And then we're going to have this now to the power of 10. So hopefully, what did we have? Yeah, we'll do that one. So let's, that looks good. Okay, using the closest interpretation. So, right, okay, we need to get rid of that, don't we? That's fine. That looks good. Let's see what we're going to get on here. So let's check. Right, okay. So does this look good? Remember, this is an expanded form in descending powers of x. We generally write it in ascending powers of x. So before I multiply through by 3 to the power of 10, we've got 1 minus 10/3 x plus 5x squared minus 40 over 9x cubed. So that is this bit right here. Let's just get rid of that. These are the first 4 terms. And all we need to do at this stage is go ahead and multiply through by 3 to the 10th. 3 to the 10th is going to, as I said, it's going to be huge. So 3 to the power of 10, well, 3, not 30 to the power of 10 is going to be pretty big. So there we go, 59049. So what I'm going to do is 590, so 59049, that's the first term. So let's just check that, and then I'll just shift store A, and then we'll times this now by what have we got, 10 over 3. Again, I could probably do this without messing about, but I'm not going to waste the time. So 196830, so that's going to be negative 196830. That looks good. X on there. Let's just check I've got that. 196830. Okay, and then if I multiply, so recall A, that's the answer, and then I times that by 5, what are we going to get? 295245 plus 295,245, and that's going to be x squared. That's a positive. Okay, and let's just check that I've done that right. 295,245. That's fine, and then we'll multiply this now by 49ths. So that will give me now, when I make it negative, the cubic term, 262,440. So minus 262,440x cubed. And that gives us now the first 4 terms, or the term up to and including x cubed. I personally wouldn't have used this method. I would have gone for the NCR method, because, again, we've got to take this 3 to the 10th out. If I did now 3, what have we got? 3 minus x to the 10th, positive integer power, I just simply write this now, 10c0, we'd have now 3 to the power of 10, we'd have now negative x to the 0 plus 10c1, 3 to the power of 9, we'd have negative x, which we need to take to the power 1, 10c2, we've got 3 to the 8th, then we've got now negative x, which we need to square, plus 10c3, then we've got 3 to the power of 7, then we've got negative x, which we need to cube. A lot easier. But if I had, for example, 3 minus x to the power of negative 10, that is not going to be a possibility. Therefore, I would simply take out the 3 to the power of negative 10, 1 minus x over 3 to the negative 10, and then I would simply use this particular approach, this time with n is equal to negative 10 instead of positive 10. So as you can see, when we're using the method 1 plus x to the n, or 1 plus ax to the n, that value must be 1. If it isn't, we take it out. Right, question E. Well, question E is a bit of extension relative to this particular module. You won't be tested yet on fractional powers. The reason I put it in is because we can see how much easier it is if you're only going to use one approach to use this approach. So, for example, if you're struggling to remember, use and apply the NCR method of finding coefficients or Pascal's triangle, if you learn this or use this, then you can use this for fractional powers or negative powers. So in this particular case, we've got a is equal to negative 5 and we've got n is equal to positive 1/2. So let's go ahead and do this. So we've got 1 minus 5x to the power of 1/2. Now, this will give us what we call an infinite series expansion because it's going to have an infinite number of terms. If we did that, we would say that this is going to be valid for the modulus of 1/5. I'm only putting that in there because to keep the mathematical rigour, but again, later on you will learn that. All we're going to do is expand the first 4 terms. 1 plus n, which is 1/2, multiplied by ax, which is negative 5x, plus n, which is 1/2, n minus 1 is negative 1/2, then we're going to have now negative 5x, which we need to square, and divide by 2 factorial, which is the same as multiplying by 1/2, plus n, then we're going to have n minus 1, we're going to have n minus 2, minus 3 over 2, we will have now the negative 5x, which we need to cube, and we'll divide this by 3 factorial or multiply it by 1 over 3 factorial, which is going to give us 1 over 6. So you can see now that this value of n is never going to end up becoming 0 because we've gone past it. Because we go from half, we subtract 1, we subtract 1. So it's an infinite series expansion. So this is going to be 1, and then we'll subtract 5 over 2x. This is going to be now negative. We've got a negative, and then this negative squared, which is a positive. That's going to be negative 25 over 8x squared. This one right here, we're going to have now negative 375 over 16. At a quick guess, let's just put this in negative. I'll take a punt at that, and then if I'm wrong, I'm happy to hold my hands up. Negative, what are we going to have? That's going to cancel off with that, the 2. So negative, what are we going to have? Negative 125, well, it would be negative 125 x cubed over 16. I'll just put that for a calculator, plus so on and so forth. And I'm just going to put here that if this is an infinite expansion, we just have to put that it's valid for the modulus of x of 1/5. You don't quite need to be comfortable with that yet, as we discuss it in a further video. It's just, I can't leave it off there. So what we'll get then is, let's just do this then. So what we're going to have then is 1/2. And then we're going to times that now by negative 1/2, and I'll see if it'll just, let's see if we can go just with these, negative 1/2. Then we're going to have, now on here, we're going to have the next one, which is going to be negative 3 over 2, or negative 1.5. So negative 3 over 2. Then we're going to have on here the next one, which that's going to be negative 125. Negative 125. And then finally, we're going to do, what's this one going to be? Positive 1.6. So let's go ahead and do that. Let's put that in. Hopefully that'll give me what I've got. There we go. So I'm not going nuts. Yeah. So that will be coming in a different unit. But I just wanted to add this now, just to show that we can do it with this. Because, for example, what would you use for NC on this one? So if we wanted now the cubic term, if we consider what we've got, 1/2 C3. Again, if you put that in a calculator, let's just put that in. So 0.5, and then we have C3. It's going to give us an error. So again, this is how many ways can 3 items be chosen from a half. So that's why we use this particular approach. Okay, let's move on and do one more question, and then we in a later video we will look at some more challenging ones, right? Relatively speaking, because I think these are quite challenging. Given that n is greater than 0 and the coefficient of the term in x squared in the expansion of 1 plus 2x to the n is 40, we need to find the value of n. Now we can jump straight to this, so let's just grab this up. So let's put this on. So what we're interested in now is the squared term. So the term in x squared. Well, this is the term in x squared. So what I'm going to do is simply go ahead now and write this out. So what we've got then, in this particular one, we've got 1 plus 2x to the n. Now a is going to be 2, and n is going to be equal to n. So let's substitute this in here. And what I'm going to write then is n, we'll have n, then we'll have n minus 1. Now this is going to give me, if I substitute in here, we're going to have now 2x, which we need to square, which is 4x squared, divided by 2, that's 2 factorial, and that is going to be equal to 40x squared. Of course, we didn't need the x squareds in, as we're just considering the coefficients. I've done this for completeness. But hopefully from here, what you can now see is that we have the following. So we've got n minus 1. This is going to give me 2. So if we divide both sides by 2, that will be 20. So we've got n squared minus n minus 20 is equal to 0. And we can say now that this is going to be n minus 5. And then we're going to have n plus 4 is equal to 0. N is equal to negative 4, or n is equal to positive 5. N is not equal to negative 4, as n greater than 0. Therefore, we can say that n is going to be positive 5. So in using that approach, we've used this particular method now to go ahead and find the value of n where n is an unknown power. And this is the advantage of this particular approach. So there we go. That's an introduction to the 1+x or 1+ax to the n method. That is given in the formula book, 1+x to the n. You simply need to substitute in and we can go ahead and use it to solve problems. So in later videos, we will look at some more challenging examples.